Ready to go. Thanks again to Microsoft for the Subway lunch. I hope you guys got everything that you wanted, food and drink and everything. So let me introduce David and Zach. They are from Source. They are going to be talking about app service environments for highly compliant environments or scenarios, and they can explain what all that is. And yeah, take it away, guys.
So, a bit about us, marketing stuff, just kind of some background on Source. We're very focused on financial services and other highly compliant industries, focus on onboarding organizations to pretty much all the public clouds, so Azure, GCP, and AWS. Obviously today we're going to talk about some of the experience we've had with app service environments in Azure. So we're going to provide just some background of why you want to do this, and then kind of an intro into some of the challenges we faced, explain why ASE is the thing to use, at least for the moment. Then we've got some demos, and I think Zach's going to cover off some of the deployment plans.
What ASE? Because we didn't define the acronym for the.
It's an app service environment, or application service environment, and I'll explain what that is in a minute. Cool. So you can just go through the way. So, let's leave it for what, isn't it? There we go. Yeah. So we're talking about PaaS here, right? Like you probably covered this off this morning. I'm going to skip through these first few slides because it explains what app services are in general. So we're talking about PaaS. Yeah, and did you cover off like the use cases, mobile apps, web apps, API? Did you cover all that? Okay, we'll go back. Yeah. So. Most of the focus for Azure App Services are in web apps, but you can also run Azure Functions. There's mobile apps, which effectively like Azure Web Apps, but with additional API hooks to do kind of mobile things like telemetry and that kind of thing. And then API apps, so it allows you to surface your organizational APIs in a managed format. So there's more than just web apps in Azure App Services. All app services sit within an app service plan. You probably saw that as they were getting provisioned this morning. That's kind of like your virtual performance throttle and billing container for app services. So you can have multiple app services in a single app service plan. Yeah, pretty much it. Yeah.
Supports lots of different
Lots of
frameworks.
stuff. With the work that we've been doing recently is putting Java apps in an app service environment. So if any of you are familiar with Java, we've effectively been taking the WAR file and pushing that into an Azure App Service that's effectively running an instance of Tomcat under the covers and then providing an app. You obviously do with .NET and some other stuff, but basically all of these are supporting pretty much anything, to be honest.
Yeah. You can actually, because it runs in the app service environment, you can run it runs IIS. So these are the supported frameworks where Microsoft will take care of everything up to the runtime. But there are marketplace runtime environments you can pull in. Pretty much anything you can imagine is ready to go there.
Yeah, and there's a couple of extra features in preview. So I think there's a Linux instance, so rather than running on IIS, there's actually Linux under the hood. Yeah. And I think there's another thing in preview where you can actually push Docker containers into an app service and actually run it on top of a Docker container.
Yeah. So if you have a scenario where you need to be in more control of your configuration, these integrate really well with the application settings that are exposed through the Azure portal. But if you would have a more custom configuration, like in Tomcat, I need to hack apart my server XML. You can actually put a Tomcat instance directly in your www root, and then you can configure every single piece of Tomcat you want to. The default one out of the box just basically allows you to deploy an app into web apps.
What is Tomcat?
Tomcat is a Java application container.
It's kind of like IIS, but in Java, right? So I think it's worth understanding what's going on in the background of app services in general, and also this kind of explains what an ASE is in more detail. So when you were looking at the deployment examples that you had earlier today, what you're actually doing is, via the management APIs here, you're actually deploying, you're deploying via deployment service and the management API into a storage controller. And then when you either spin up the Azure App Service, or someone actually hits your Azure App Service, what it's going to do is it's actually going to go via some metering of the deployment services. Once you've deployed it and you've configured it, all that stuff's stored in a runtime DB. That's where all the configuration settings are. It'll spin up web servers dynamically, load your solution from the storage into that, and then set up in an application request route cluster. It's going to use HTTP routing to send the users through to the cluster that it's spun your app service up on. Right. So that's. I can do a whole presentation on this. I'm just kind of explaining what's going on underneath app services, right? So this is the underlying logical solution that Microsoft have underpinning all app services. So I'm just going to go through that again because I did that pretty quickly. So an app service environment has a load balancer that Microsoft provides you. So when people hit the endpoint that Microsoft is going to provide, there's a load balancer that points to a cluster of application request routing servers that does HTTP level routing based on the request in the header, which eventually will end up on a set of, in app services in general, it's a set of shared web servers. In app service environments, actually dedicated web servers for you. The application request router finds that logic from a runtime database that gets provisioned when you configure your app service via the Azure portal, or if you do it through ARM templates or the Azure CLI or whatever else you want to do to configure it. That's all popped in from the runtime DB. And then the stuff that goes onto the web servers, that gets deployed by deployment servers into storage. I think Rob said earlier that, I think Akib actually asked about session state. All of these things are completely transitory, right? They're ephemeral, it can scale out, scale back again. There's no persistence here at all. The persistence is at the storage controller level, right? So you shouldn't make a decision to actually store data here, because at any point in time that disk, that server could be whipped away, and then it'll re-provision it based on what's been set up as part of the deployment process. Right, so there's a whole line of infrastructure. Any questions about that? Because that's pretty complex.
If you on the web application, if you get some data from the world,
Yeah.
How does it connect to your storage? Because I want to keep some. I want to see if this guy likes me or wants something from me.
So
how does you
would put that in a database.
You put us in. It's like when I think you keep asking about session state this morning, and Rob said you should use Redis for that. If you need to persist any data, you need to attach it to some kind of external storage. That could be Azure Blob Storage, it could be a database, or it could be Redis. There's lots of storage options, Cosmos DB, lots of persistent storage options in Azure that need to be outside of this solution. You shouldn't persist any data here at all.
Does Azure provide some sort of mechanism to pull off log files off these ephemeral
Yes.
Oh yeah.
instances?
Actually, I'm not sure if we're going to see this in the demo.
I can walk through the logging settings, but you can set it to a specific time or whatever, a certain window, and it'll put it in a storage account for you.
Yep.
So all the diagnostic logs, the application logs, even the access logs.
Yes, and then Microsoft is pretty sure the cloud providers have additional telemetry services that you can consume.
Mm-hmm.
So in Azure there's log analytics, which was OMS, and there's application insights. In AWS there's CloudWatch.
Right.
So if you're looking for that kind of stuff, you really need to integrate it with an external telemetry and monitoring engine.
There's a question.
So all these components can be accessed, or it is just behind the scene?
It's completely behind. It's transparent. You don't get to see this.
Okay.
Your experience is the experience that Rob showed you this morning, and we're going to show you later on.
Okay. And one more question. I don't understand what is the use of IIS ARR as the load balancer. We already have load balancer before.
Yeah. So basically, your cluster service here, right? It's an IIS web plan. Right. You can host multiple app services in your app service plan. Right. So I can have food.com, source.com, whatever.com.
Right.
But that's all hosted in my cluster service. So the LB is effectively just load balancing across the ARR service, and the application request rate servers are doing IIS level routing to determine which server to send it to.
Okay.
Yep.
Thanks.
So challenges for app services in the enterprise. Well, number one, they're directly internet facing, right? And In fact, you can put, like, Microsoft has a solution called an app gateway, which you can put a web application firewall or WAF in. That only works if the stuff you're writing to is on a VNet within Azure. App services directly attached to the internet, so you can't use some of that stuff. So I know there's a DDoS service that Microsoft has just launched, but effectively, when you're looking at an internet-facing app service, you probably only have like level 3, level 4 protection. Like it doesn't go any further than that. So things like SQL injection and that kind of good stuff, like that's not available. And it also means from a logging point of view, if you need to log even the packets, you can't scrape those off and send them somewhere else because it's going directly on Microsoft's shared infrastructure that you're sharing with all the other tenants that are using it. So that's a problem. And yeah, like multi-tenanting, and yeah, cut off all monitoring all those things. So there's a challenge. Like if you think of transport companies, banks, anywhere where there's compliance, the fact that the internet traffic is hitting the app service directly and isn't going through any control plane, isn't going through any monitoring and auditing plane is a big issue.
What about OMS, like logging up? Does that help or?
But that's not going to give you the kind of network visibility that you might need for PCI compliance, for example.
Oh,
right? Yeah.
You had a question?
Oh, maybe I'm gonna wait.
Okay.
Okay. Cool. So I think it's still you then, right?
Yeah.
Okay, I'm going to stand over here.
Before we get into the app service environment, we'll just touch on VNets really quick. VNet is essentially it's a virtual network that you can deploy inside your subscription. So if you want to use private IP addressing, you don't want everything accessible to the internet, you're gonna create your own VNet. It enables your network-based isolation. So if I, want to have secure access to resources back on-prem, I'm going to build my own sort of VNet structure, have an express route connected on-prem, and we'll get into that design pattern later. So yeah, we'd be using VPNs or express route to connect back to on-prem. And the ASE that we build gets deployed right into that VNet. App service typically is it's a platform, so it's not deployed directly in your VNet. You don't have that layer of control, right? You can integrate certain parts of it with a VNet, but you won't get that whole network isolation with all of the MSG logs you might need.
Just to put in perspective, Source is your company.
Yes.
App Service Environment, is it your thing or is it Microsoft?
No. This is all Microsoft. Yeah.
So and just a dumb question that really hit me for 2 days. Like when you have a mobile app versus a browser-based app, okay? It looks a lot similar for something that's very clever, those things. But is it because they all use HTTP address and stuff like that, and the IP address, right? What's the big difference? Is it they use a browser as a background for the things, or they're very different?
So a mobile app, it would typically be, the extra piece would be identity management, right?
Yeah, but it's not just that though. So think about if you're getting a website, if you're a web developer, right? You're capturing all the requests and the usage of analytics on the server side. It's very easy to get some insight into how your web app's being used because you can scrape the gets and right. It's pretty easy. From a mobile app point of view, if I want to know what the best feature is, or like where people are clicking, or what the user flow is through the mobile app, I can't do that because all that's happening on the device. So one of the biggest challenges for mobile apps is actually picking up that telemetry from the mobile application.
Because you have the cookie or something telling you back a lot of stuff. So
well, it's not just that. Like in terms of,
There's a framework called Crashalytics that you
Yeah.
build up on and attach it to your mobile app.
okay,
Make it part of it.
like
but if you go into a browser-based
Yeah.
app that can run a mobile or a PC, do you have that from the browser or no?
if it's an HTML5 app that's effectively, it's the same experience. You're just modifying the style sheets on the page. It's effectively a web app. But, we're talking about mobile apps, and we're going slightly off topic. But
Sorry.
yeah, but if you think of mobile apps, like if you want to capture user performance, because it's actually running on the phone, it's very difficult to capture that. Whereas on the web app side, it's actually reasonably easy to determine performance issues.
Okay, when you say a web app, when you say on your phone, you talk about a browser-based kind of thing, right?
No, you're talking about the actual app, like a parking app or.
Okay, our web app is the web, the things run on the web. And
Yeah.
just- just go to your phone as a kind of you have an application on the phone that's like a browser.
Mobile
interface.
apps just have specialized frameworks,
Yeah.
right? And their Azure has an easy way to deploy those frameworks into the app service.
Yeah, and we can check
Okay,
that.
sorry.
Yeah, no worries. So there's a few different use cases for the ASE. If you need pure network isolation, let's say you wanted to run, like this workload was perfect for Azure and you only wanted internal clients from your enterprise to connect, nothing from the internet, you could use an ASE for that. They're actually larger scale than the typical multi-tenant, so
I think we've got some numbers about that later.
yeah,
Yeah.
they're larger scale and they're specialized hosts. So if you have a very high performing web application that you need guaranteed performance for, you might consider putting that in an ASE. You were telling me about you guys did your first deployment with ASEs was a Super Bowl commercial.
No, so
It was a site.
It was a media streaming thing,
Yes.
where they were doing some sports streaming and they wanted guaranteed performance.
Yeah.
Yeah.
And this works with all VPN types, ExpressRoute, and otherwise. Yeah, we already touched on this. So ASEs allow you to go up to 100 app service plans or 100 instances. So when you're talking about an instance, it would be the actual host. So in the ASE, you could have 100 app service plans of a single instance each, or you could have one app service plan that could scale up to 100 instances.
Yeah, I think
Any mix of that.
Yeah, I think it's only like 20. It might be 50 for premium apps. If you're doing a traditional app service, you might only get a maximum of 50 instances.
So you can have more 100 users?
No, 100 nodes running your solution.
You could have 100 servers.
Yeah.
Yeah.
Then each server can run X number of users.
Yeah.
Yeah.
And so the amount of apps you can actually have is fairly high.
Yeah, it's,
I don't know what the actual limit would be in the
Tens
of
of
the ASE,
thousands,
but you could have 10,000 apps in one ASE.
yeah.
Okay, so isolated, these are the specialized pricing plans just for the ASE. It doesn't have the price, no, we don't have the price there.
No.
It's very expensive. So, yeah,
1,200, that's more
It's-
what I think.
Yeah.
it's 1,700 Canadian for the ASE.
Okay.
Depending on the region, so Canada Central is a very expensive region. East US 2 is a little cheaper. So it's about 1,700 for the ASE, and then on top of that, you have to pay per instance that you're using. So they have I1, I2, and I3. Those would be your host types, and even each one of those would cost maybe $300 or $400 a month per each instance. Yeah, so not cheap.
So this is per year, per month?
Per month.
Per month.
Per month. So
So you actually pay kind of like per minute.
yeah.
But the numbers that we gave you, if you had it on 24/7 for a whole month, that would be what you pay for.
Okay, but if you control, let's say from 6 a.m. until midnight, something like that.
Yeah,
It'll
yeah,
be cheaper.
it'd be cheaper.
Yeah, you could do that. The only consideration there is it takes just over an hour to build an app service environment,
So
and then it takes about another half hour to deploy an app service plan in that environment.
So it's not,
So if you're going to rebuild that kind of, it takes some time, right? The provision, so that all that infrastructure that David showed, that's all being prepared for you in a single tenant environment, right? So it's dedicated to you in some sense. It's probably sharing virtual machines, but all of those, like the request routers, the load balancers, the storage accounts,
SQL.
everything, the SQL, everything is spun up and dedicated to you behind the scenes.
how safe and robust against invasion?
It's
Pretty much bulletproof.
So
Yeah.
you
You're
can't-
not sharing this.
well,
with
hold on.
anybody.
It's always terms and conditions apply, right? So it's
Yeah.
only going to be as secure as the solution you deploy into it.
Right.
But assuming the solution you deploy into it is secure, then it is pretty.
By solution, you mean the provider who does it for you, or?
Yeah.
What is Microsoft spends roughly 30
Well, Microsoft spent.
million on security? No, more.
No, it's like 2 billion. So,
Yeah,
so
2
it's like,
billion.
I think Microsoft spent about 30 billion on cloud last year, and 2 billion of that was just on security.
It's always an interesting conversation because you get asked about cloud security. Is the cloud secure? It's like all these providers have more security certifications than any company I've ever worked for could afford, right? Yeah.
Yeah, I have been very much confused about ASE. Basically, if I deploy just web app or any app service without ASE,
Yep.
it is publicly interfaced.
It's publicly addressed. Yes.
If I want to make it either private or just for the particular specific users through VPN, then ASE is the solution. That's right. Okay.
That's right. Yeah.
Well, you can in a traditional app service.
You could do an MSG with firewall rules.
Yeah, you can put
something like that.
you put some rules on top of it, so you can restrict the people that are able to access it by IP. But if you want to make sure that it's only coming from on-prem and channeling through, your only option right now, today, is an ASE.
Yeah.
Now that's going to change, but today it's just an ASE.
Yeah. So this is one of the patterns for ASE. So we would you can have an external facing ASE. There's two modes: external, internal. External is going to mean you have an external VIP, so you can actually come directly from the internet into your Azure Virtual Network, and all that's routed back to your app service environment. And then the internal mode would be you have an ILB here, right? So that's internal only. So from on-prem, you're going to access this over your express route. This is a private IP address, no internet involved, directly into your app service environment.
Yeah, so you have two use cases. Like this is the performance one, when you want guaranteed performance,
Yeah.
and then this is the secure one where you only want traffic to be coming from on-prem.
What's ILB and VIP stand for?
So VIP is a virtual IP.
Okay.
Yeah. And then ILB is an internal load balancer. So it's
Internal
a
what?
internal load balancer.
Load balancer.
Yes. So it's a strictly internal facing load balancer. Actually has a private IP, won't respond to public requests.
We covered off all of this.
Yeah, we did. We covered off most of this stuff.
Yeah. Oh, sorry. It's worth noting about the names here. So you would have saw this this morning when Rob was doing his demos, where because it was an external facing app service, it had a Azure Websites.net or cloudapp.net URL. If you have and we'll show you this in a minute, if it's an internal facing ASE, it actually has a domain name, an FQDN that you can actually configure. And you have to figure out the DNS resolution and all that good stuff.
Okay, so we have some deployment patterns here. So external ASE, the deployment pattern would be you're going to interact directly with the external VIP. So they're going to give you an endpoint. It's going to be a fixed public IP address. And that's your deployment endpoint for if you're going to use like FTP or MS Web Deploy, something like that. So you can still use most of those patterns that Rob presented. In an app service environment, you'll see when I pull up the walkthrough, it's when you actually have an app service in an app service environment, it looks exactly the same. You get most of the same options. It's all still there. So you still have, in this pattern, you would still have outbound internet access. So you could hook this up to a Bitbucket repo or Dropbox or whatever crazy options you have. Okay, so this is ILB with WAF. This is another pattern. So when we're dealing with premium app services, we can't put an application gateway in front of it right now, I believe. That's not possible at this time. So if you wanted to have a very strict WAF, Web Application Firewall, that Rob showed, in front of your...
Roy. It was Roy then Roy.
Oh, Roy then Rob. But Rob, you showed... oh no, Roy showed the WAF. That's right, sorry. So much app service talks today. So yeah, if you want to put a WAF in front of your app, you're going to have to use an ASE. So you can have an application gateway here pointing to your ILB, and this is actually what we've created for the walkthrough. And then this would just be a geo-distributed pattern. So if you wanted to you could have a traffic manager here and your two application load balancers, your application gateways.
Yeah, so the kind of scenario we use is there's a couple. Let's say I wanted, my people using my solution were, from a geography point of view, very, very disparate. So I had people in Japan and people in the USA doing it. I wouldn't necessarily want to send them all back to the same app service instance because the latency of the traffic coming from Japan all the way to North America, would make the app unusable. So what I'd have to do is effectively have two app service environments in two different Azure regions, and then I'd use the performance setting on a traffic manager to send people to the different application regions based off of how close they are to the various regions. The other scenario of this is if I wanted to do zero downtime deployments. So if I wanted to make sure that my application was always up, even when I was in a maintenance window, what I could do is have, again, the applications, the app service environment deployed twice, and then use Traffic Manager to say which app service environment I set people to based off of some custom configuration that I've configured. So let's say I wanted to update this environment. I configure Traffic Manager to send everything here. Update this environment, test it, make sure it's all good. Then configure Traffic Manager to send everyone over here, and then make those similar changes on this side of the fence.
You could also do, with this pattern, you could have some sort of A/B testing or canary situation. So if you want to enable some brand new feature, very cutting edge for 10% of your users, you could route 10% of traffic requests over here and the other 90% over there.
So are there 2 ASEs in this?
Yeah, so this would be 2 ASEs in likely 2 different regions, right? If you were geographically disparate, so you'd have one in Asia and one in US.
You probably, like if you had 2 different ASCs and you wanted to do it for this, it just kind of falls natively into your continuity planning for this, that you put them in separate regions, so that if there was any issues that Microsoft had in a specific region, like your kind of
Your app
protection
goes
as well.
up.
Yeah.
Forced tunnel ASE. So this is the land of fun that we've lived in. So forced tunneling is when you have an express route connection back to an enterprise network. So that would be connected to one of your VNets or a bunch of your VNets. And you actually broadcast the default route from your on-prem network into Azure. So you say, I want all of my traffic can't go out to the internet. We can't go leave the VNet for anywhere else except via express route or a peer. Right, so we would have a bunch of VNets peer together, and they all travel via express route.
Yeah, you got UDR for that. Sorry, it uses defined route.
Yeah. So then it forces all our traffic. So our default route 0000 is forced back to our on-prem network. This comes with a world of complications with management addresses. Essentially, when you do this, when you're deploying the app service, there's actually a lot of complications with communicating back to the management endpoints. So the traffic doesn't stay on the management plane in Microsoft. It actually routes through your express route, through your network, all the proxies, and then hits all of these various endpoints. So there's a few different patterns you have to look at. You can have your security team whitelist all of these various services in their proxies, so we would be able to hit them directly without modifying the traffic. Because essentially what Azure is dropping is, if I come from my ASE and I'm making I need to make a management call to something in the Azure network, right? And it gets routed back and then natted and then comes back into Azure, they're going to go, I don't think so. They think that's spoofing, right? There's not a chance they're going to accept that. So you have to either come up with a whitelist, or you can actually, Microsoft gives you a list of all of the management endpoints that you need to talk to within the ASE. You can create a user-defined route table and allow just those routes out of your network. Right, so that's
from the virtual network, right? Not through the
So
express route. Okay.
So instead of all of this management traffic going out this way, we're actually we have a user-defined route table, and you can allow that traffic to hit those endpoints and only those endpoints, and everything else is forced tunneled
So
back.
in the real world, do compliance and security teams accept that?
Yep.
Yeah.
Okay.
Yeah, we had to get an exception for it, so we had to go through a whole design review with the information security team, but they agreed that was the proper way to do it.
Yeah, the main challenge there though is the IPs that you're whitelisting, right? Like how permanent are those? Like Microsoft is continually updating their environments and updating everything else. Just because you've whitelisted them today doesn't mean they're going to be there tomorrow.
Yeah.
So there's a whole automation and management piece, which I'll probably mention later, right? Or not? I don't know. Are you going to
I don't.
Okay.
We haven't really built that out yet,
Yeah,
but there's an internal ARM API that you can hit to actually pull all the management interfaces out, and then you could write some sort of Azure function to keep your UDR up to date, right?
Yeah.
So there is some room for automation there, but
good news is Microsoft know this is a problem, so they're going to be updating some of their services, and ASC is going to be one of those. That rather than having to whitelist an IP, you can whitelist the FQDN as a service.
yeah.
So these are all public IP addresses from the management?
Yeah.
So I'm sorry. Go ahead.
No, go ahead.
I missed where do you set up these endpoints? in when you set
So
up
if
the
you were
first
going to build an ASE in this scenario,
right.
there's a page you can visit in the Microsoft documentation that is actually called Force Tunnel in
Right.
ASEs, and it'll link you to a page where they give you all of the management interfaces for ASE that you're going to need. Right? You create a user-defined route table for your VNet.
Yeah.
With all of those IPs, and there's like 50 of them per region, and they're different per region. And what that does is it says when we hit that route table, because the user-defined route table is always going to take preference over everything else, right? So when we hit an entry in that route table, it's just going to allow it out of the right? So it's going to allow that directly to that storage account or whatever it needs to call.
Okay, even though we have set up Force Tunnel to go to on-prem, only for those services,
That's right.
it will allow that.
Yeah. And that's the pattern we had to get approved through the information security team and all that stuff.
But I think it will still go to the internet, right?
It doesn't go through internet. No, it's going to be an internet IP. It is a public IP, but it's within an Azure data center.
Yeah, Azure
Right.
only to
And I mean, because we're in this scenario, Microsoft is a trusted vendor. There's an enterprise agreement in place. They would trust that traffic is going to end up at its intended location, right?
Okay.
Yeah. We already talked about all this, so supporting Force Tunnel configurations. I'll do a quick walkthrough of deploying an ILB ASE.
You don't have to wait the full hour.
Yeah. My
That's very loud.
screen resolution is terrible right now.
Yeah, you're good.
Better?
Much better.
It's a bit. Oh,
Okay, let's drop that to 720. There we go.
1080p is too much.
Yeah. Okay, so
you can all see this, right? Yeah.
we're going to create a new resource group here. We'll call it Azure.
I'm assuming this morning it's all been covered off, or a resource group is and all that good stuff.
Yeah.
Yeah.
So we're just going to walk through deploying an ILB ASE because there are some tricky little things. We obviously won't wait the full hour because that's crazy. So I've pre-provisioned an ASE that we can walk through after that. So basically, I'm just going to add a resource here. Now, when you do this through the portal, which you shouldn't because it's not version controlled, right? It's going to create, so when you create an ASE of any kind, it's going to create the VNet and the subnet and all that stuff for you. If you're doing this through ARM templates, which you should be, you're going to have to pre-provision. So you have to build your VNet, your subnet, you'd have to build your NSG, and then you provision your ASE into that.
Zach,
Yes.
would you increase the screen size of the browser?
Yes. So better?
Bit better, yeah.
Okay. So app service environment.
Yeah, you don't want B1.
Yeah, you. I don't even know why that would be that available. We'll call this AW Azure.
Right. So there's another way. Whilst that's talking about this, there's another way that you can provision app service environments, and that's you just provision an app service and you set it up in an isolated mode. The problem with setting up an app service in an isolated mode, which is going to give you an app service environment, but it doesn't give you this option here, right? So it's going to by default set it up as an external ASE, which isn't going to allow you to do false tunneling and all the good stuff that we just talked about.
Right. It's also not going to let you put an app gateway with a WAF in front of your application. So if you want that type of deployment pattern, you have to come here and create your internal ASE first, and then you create your app service plan, and you actually point it at the app service environment like it's a region. So the app service environment comes up in the region list as a separate deployment spot. So kw.demo.local. The domain itself, this isn't integrated with DNS in any way other than the request routing. So the DNS you create when you create app services and it spins up, it'll tell you the host name like application name.kw.demo.local. There's going to be no DNS created for you at all. So you're in charge of managing that.
So the isolated environment, there's no SSL offloading, I'm imagining, because there's no.
SSL offloading, SSL is terminated at the internal load balancer.
Yeah.
So that's where you configure your certs.
Yeah. So the kind of is. So
Because
the
of it, it's not.
kind of is, yeah.
We'll see if it tells us how much an ASE is here. Yeah, so there's your, I was a little bit wrong. So there's your monthly app service environment fee. And then your smallest worker for one is $360 per month.
Yeah, so all the underlying infrastructure that we talked about, the request routes, the load balancer, the SQL box, the deployment storage, all that stuff, that's what this is paid for. That's what you get in there. You're not getting an app service. You don't get the app service until you start paying these things.
I'm surprised they don't have a like a checkbox. You have to actually agree to this before you sign up. Yes, we'll pay that much.
Please verify your credit.
Yeah. We're going to check your limit really quick. So this is going to go off and create it. This is going to take a very long time.
Yeah, we come to the conclusion, because it takes so long to do it, these app service environments are semi-permanent constructs, right? It's not like an app service where you can spin one up, like Rob demonstrated this morning. It's not like an app service where you can spin them up and spin them down on demand, because it takes an hour. It's not something that you can do with a very responsive fashion. So,
Yeah.
so if you're planning to deploy these into your environments, you should treat them as if they're semi-permanent resources.
I think the idea here is that you would share this app service environment amongst many applications within, if you're working in an enterprise and you have many lines of business, and some of them each have different security requirements, you might have different regulations. You would line them up so that, in this ASE, you could have all of those line of business apps in that one environment. They're meant to be shared, right? Because you could have 10,000 apps in there, no problem. Let's have a quick look at what we've already provisioned. So I'll go back to
In best code, we show slide.
yes.
Yeah, here's what we
Voila, it's done. So what you would see is that you would get when you provision the ASE internal, you get VNet, an NSG, you get a subnet created in there, and then you get your app service environment. I've also deployed in a separate VNet, we have an application gateway with a WAF, and those are connected via VNet peering.
Yeah. So this was the only resource that's not deployed by default. Zach's added that
Yeah.
for the purposes of doing it.
So it creates the route table for you, all that stuff. So let's have a quick look at the actual app service environment. So there's not too much you can actually configure here. This is more where you can drop a cert, you can get your IP addresses. So what you'll see here is that we actually get, so we get a little bit of information here. The domain that the ARR is going to respond to, so that's going to be our base domain when we create apps. So if we create app1, it's going to be app1.azure.source.io. We get our internal load balancer IP. There's an outbound IP. So by default, even though it's an internal ASE, we're still allowed to connect outbound, right? But in a forced tunnel situation, all of that traffic is going to go all the way back through your enterprise network and then back out to wherever it needs to go. And then you also get an open IP address.
Yeah, one of the interesting things is you can define this address, but
Yes.
it seems it's always 11 for reasons.
Yeah.
But anyway.
So you can configure your ILB certificate.
Yes. So you're asking about SSL upload.
Yes.
This is really good there.
So this would probably be a wildcard cert for your whole domain that you would configure here. It would just make life a lot easier.
Or a SAN if you have multiple.
Yeah.
This is actually interesting. So there's worker scale in your app service plan, and then there's front end scale in your app service environment. Front end would be those actual ARR LBs. So those can scale up and down dynamically as well, and you can set that here, what type of worker you want, but you're still charged for them.
Yeah.
So it's still $360 for one I1 with 3.5 gigs of RAM.
Yeah, Azure is just like you as a provider, consumption-based model, you pay for what you use.
Exactly. And then you can have those tunables there. One thing we learned this week is that ASEs do not integrate with Azure Security Center yet, right?
Yeah. So one of the things we were going to talk about today was compliance. So you don't just put a control plane in place. You need to be able to monitor the control plane to make sure it's continually compliant. Azure Security Center, which is I think there's a bit on the bottom there. somewhere.
I don't have it.
Oh, you don't have
Security
it?
Center right here.
There you go.
Yeah.
That has a ton of pre-configured compliance settings, so you can see how compliant your solutions are. It will monitor app services. The problem is because your app service is in an ASE, Azure Security Center doesn't have the ability to look into that, so it can't tell you if it's compliant using Microsoft's app service compliance tools.
So you cannot monitor through Azure Security Center?
Yeah, that's correct.
Okay.
The NSG flow logs, all the infrastructural components you can do, but it can't look into the app service.
You could still capture all of the traffic coming into and out of your VNet. So if all you have deployed in this VNet is your ASE, you could still capture all of the flow logs coming in and out of that. Right?
Yeah.
So it gives you a quick breakdown of your app service plans. I have one here.
Well, you were saying the AC is very secure, so you don't need the security anyway, or?
But like I said though, regardless of how secure it is, from a compliance point of view, like if the auditors come, you can't just say, look, it's secure. Like you need to be able to prove, you have to be able to prove it to them, right? Yeah.
That was just one question.
I won't get into this too much. So this is a typical app service plan. The only difference is when you create this app service plan, you specify that you want it built in an app service environment, and that allows you to use these isolated instances.
Yeah, we normally go a bit deeper on this, but this has already been covered.
This has already been covered, so I'm not going to spend too much time on it. If I go to my actual app, so as you can see, all of the options are identical. It's all the same. It's just this is responding behind an internal load balancer and isn't available publicly. The only reason it is available publicly is because I've taken an app gateway with a web application firewall and pointed it at that ILB. So I've created this endpoint, and I'm not a developer, so I'm not going to write some fancy application. This is your app service up and running. This is a better splash page than I could ever put together. Yeah, so this is responding behind. This is an application gateway with an ILB behind it, and then we have some basic web application firewall rules. Yeah, so that's pretty much it for building ASEs. Is there any questions about that?
The question in regard to this gentleman asked about SSL transformation. You said it is happening at the load balancer.
Yeah.
Generally, it happens at the gateway, right? Application gateway.
If you put the WAF there,
So you could, and if you wanted to actually enable SSL between your application gateway and your ILB, because you're super paranoid, you could do that as well. So you could have certs on both sides, right? Yeah.
but you'll always need a cert for this though, right? Because the app service can't be configured and it can't be, you can't use Kudu SEO. You can't use that over HTTP.
Without HTTPS.
So you're always going to need a certificate for app services anyway if you want to do that stuff.
Okay.
Oh, I could have created that,
If-
record to show that.
If it's a cloud, whatever it is, the standard app service, Microsoft's going to give you a certificate for that by default. Or if you set up a custom one, then you're going to need your own.
That's incorrect.
Yeah.
How much do you think you save by using the ASE versus, taking all the Azure bits and going, okay, I can get an ILB, I can do all these things and all this. What do you think?
It's so hard to answer that question because you have to have somebody managing that stuff, right? The whole point of a platform like this is that you push the management off to your trusted vendor, right? So I can now log just a support ticket with Microsoft to take care of my ASE rather than putting together some sort of complex solution. It probably would come out to be about the same price, but I don't even know if you could build that level of orchestration
No, I don't think.
without some massive investment.
I think, like, based on the scenario we've been working on, really the only alternative would be to host a solution on VM. Right, and so I would have to then, if I wanted the same kind of auto scaling that an ASE is going to give me, I'm going to have to set up a VM scale set, manage the imaging and the capturing of that VM scale set and all that stuff.
Because we were looking at this for a Java app at a bank, there was two solutions being compared. One was JBoss on traditional Azure VMs, right? Just using a hardened image and deploying a bunch of VMs, and then the other was using the app service environment, which it was a cool exercise.
So which one is the best?
The app service environment.
What's the difference?
Well, you just get a massive level of scalability
Yeah.
because you're using a platform,
The JBoss?
as opposed to
JBoss?
using a JBoss VM and a scale set. You're still gonna have, like, you have to manage how you create that image. You have to manage your scale set. Holy crap. Those guys got confused.
They obviously want to know the Azure.
Yeah, they're excited about that.
Everybody's into it.
We're sold out, guys. Just
Yeah.
So yeah, things like if one of the nodes in the ASE gets corrupted or is flagged, because Microsoft have internal monitoring. If it gets flagged as a bad node, Microsoft manage the process of taking that node out, and you're not paying for it. In a VM scale set, you can remove the node, but it's going to stay there in a bad state until you decrease the number of nodes running on the VM scale set, and then expand back out again.
Or delete that node.
But it's actually difficult to delete a node in a VM scale set, right? Yeah. Yeah.
But
Yeah, it's easy to take it out of the scale set.
Yeah.
It's really hard to actually get rid of it.
Yeah, so you'll effectively be paying for a dead node. Yeah.
But in ASE you have limit of only 100 nodes, so you can scale only up to.
Yeah, that's a lot of. I mean, what?
It's a lot of compute.
That's a lot of compute, right?
Yeah, but if I have an enterprise,
You can go higher.
big enterprise.
You can actually go higher.
Yeah.
It says right in their documentation, if you require it, it can go probably, I don't even know what the maximum is, but you would have to log a support case and whatever, because if you scale that up to 100 of the most expensive instances, that's $60,000 plus the ASE costs,
Yeah.
plus your outbound data and all that stuff. So
And let's be honest, you probably want in that scenario, you probably want multiple ASCs deployed to multiple regions anyway.
Yeah.
For redundancy.
yeah,
Right,
exactly.
they have a limit on cores, quote on cores also, right?
No, you can get that dollar as well. It's not a problem. Yeah.
4,000.
So those ASCs, like those apps that you can duplicate on different virtual machines, you still have to purchase a virtual machine, you say, right?
No.
17,
No, so
What's
the
that $300 for? Was it like $700 was the
that's
ASC?
that's a managed virtual machine in your ASE.
That
So
take care,
it will like what all of this orchestration will do is take, if you need more capacity and you add 10 more instances, those will all get pulled into your ASE for you, and the app will be deployed and all that stuff.
So
That'll all
do-
happen
do-
automatically.
You don't have to set any consumption limit and make max. Like
Well,
before.
that's in your app service plan, like Rob showed. That's what you would have to do. So you'd set your app service plan. I thought you went over app service plans as well. Both of you.
One of the ones this morning.
Anyways, yeah.
So my point is that when it's all done for you, you don't have to decide like about those machines. You don't have to decide those things at all. It's very easy for somebody less capable.
Well, I wouldn't say it's easy for less capable because this was really painful to do, right?
Yeah.
Because of some of the networking challenges we had.
That's what you guys do.
Yeah, but that's what we do. Yeah, but it's a different level of challenge. Once it's set up, it's auto managing mostly, and it looks after itself. Whereas if we'd spun this up on JBoss on VMs, there would be a consistent management activity to keep it secure, to keep it patched.
So the
Scale.
long-term overhead is higher.
Yeah.
You set it once properly, then that's
Then
it.
you're good. Yeah.
To build an application runtime on top of a VM in a bank is a very lengthy exercise, right? There's a lot that needs to. It's not like in some smaller companies that aren't as regulated. It's I'm just installing JBoss on a VM, right? I probably have a script to do that. There's easily 12 different groups you would have to deal with inside an enterprise to create an application runtime like JBoss.
Yeah, and because
right?
it needs to be because it needs to be a blessed image, you're probably going to need to install about 10 different agents to do things like forensic detection, to do anti-malware, to do just standard compliance and patching. Like a VM image inside a highly compliant organization is not a simple thing.
Yeah.
But with these things, this is where you save lots of money.
Yeah,
Because
It actually is. Even though it's very expensive, it's still saving the enterprise a lot of money.
Because those apps does a lot of stuff for you.
Yeah.
Well, and all of the engineering time it would create, or that it would take to create a JBoss image, right? And go through all of the requirements gathering and all that you're talking about a 3-month exercise with multiple engineers to go through all this stuff. That's a huge investment as well, right?
And what is the equivalent time for you to do that with the source? Is it like a 2 weeks thing?
I think it's taken us about 6 weeks so far.
Yeah.
But the thing is, if we did it again, probably 2 weeks.
Yeah.
So like it's kind of a 2 weeks, one guy kind of deal?
Yeah.
So it's become much more affordable, but then you pay and you get a cut of the $1,700?
No, it's not like that. Sourced isn't a reseller of Microsoft services. We're just we're a partner that
Okay,
we implement.
you just make it easy for people to get there.
Exactly.
Okay.
But now
Well,
it's
look,
just
no,
a PowerShell
people do pay us for our time. You know, it's not like we're a charity, but yeah, like.
Yes. Okay, so we went some of the recent network improvements. You were saying about the host names they're adding in, so you can just whitelist those. So rather than having this comprehensive UDR that allows all this stuff, you would, on your outbound proxy, just whitelist various host names, and security teams seem to like that a lot better.
Yeah, and probably what's more interesting, like if you said, should I do this in 6 months' time? Pretty sure Microsoft's going to be coming up with a service where you can attach a traditional app service premium instance to a virtual network.
Yes.
So you wouldn't need to go through this process if you're looking for that level of security. But that's
Can
that's
you
not
rephrase
available.
that? That's pretty intense. Can you rephrase it again?
Yeah, so we set all this up because we needed to have the app services attached to a VNet behind a firewall, right? Microsoft have something coming up probably in the next 6 months where you can take an app service and just put an app service in a VNet without needing the application service environment.
So that's gonna make the overhead lower.
Yeah, substantially lower.
How
Yeah.
long from now?
Don't know.
But you're gonna be the first to know.
No, I guess it's something that Microsoft probably would know before me, but
No,
yeah.
I mean, you know soon.
Yeah.
So, in that case, do you know by any chance that if someone already has bought ASE,
Yeah.
they want to migrate towards the VNet,
Yeah.
is it?
It would be
should
extremely
super
easy.
easy, yeah.
Yeah, because it's just an app. You would be able to just change the app service plan, I believe, that it runs on, and it should
I'd probably
migrate over. I would probably redeploy
yeah,
it though.
I'd redeploy, but don't forget, like
Because all the infrastructure behind the scenes is transient, right? Where you're expecting that it could scale up and down, be erased and changed and whatever. So what you would be able to do is just create a new app service premium and then deploy your application over there.
yeah, and you saw how easy it was earlier to deploy an application
Right
through
click
a
publish.
pipeline. Yeah.
Because I don't do that every day at all, I kind of see the concept, but for it to stick, if you could have an example, can you represent a dummiest example that a layman will understand that how this thing will take? Show me an example of those app services that is inside this VNet that is there. Show me an example that's
Well,
applied. For example,
like a real world example of when you would use an
Imagine
app service
one,
inside your
the
VNet.
dummiest one
I,
because you do that, right?
No, like it's because of compliance reasons, right?
Yeah.
It could be any app, but I think their presentation is more about
The
having this,
concept.
Yeah.
Again,
the fact is that we can't, in the environment we were working in, we're not allowed to route requests via the internet to anywhere except back through the enterprise network, right? So that's why that's one of the reasons the app service environment exists, because you can't use app services if you can't accept that, unless you know you're going to be able to go outbound to the internet directly, right?
Yeah, so if my organization was concerned about PCI compliance for the application, right? A traditional app service isn't going to provide PCI compliance, so you need to do this. If you're concerned about PII data and the compliance is such that you need to monitor the traffic flow, you would need an ASE. So this isn't a technical thing, it's a security and compliance requirement for the solution you're deploying.
So another scenario, right? Flip is the application, you might have used it. Flip for shopping around
Yeah, I've heard of that.
and get the vouchers and coupons.
yeah.
So that's publicly. So if you want to deploy that kind of application, you may prefer app service without any virtual network. Because
Yeah.
you don't need security. You just want public to come there.
Yeah.
But at a bank, you might have an internal API that you don't want to ever be accessible from the internet.
Correct.
Because it reaches back and does things on-prem and you don't want to enable that access to it, right? So that would be one of the situations why you would isolate something like that.
Yeah, so for example, let's say I have a mobile application that I've written for the people inside my bank, right? And that is a whistleblowing application, so if they see anyone who might be doing something like fraud or insider trading, I have a mobile application, right? I don't want that going over the internet, right? I want that going over my internal networks. So it's that kind of useful. Like
Or government data,
yeah,
tax
exactly,
data.
exactly, yeah.
For example,
Yeah.
your SIN number series.
Yeah.
Yeah.
Okay.
Any other questions? App service environments, compliance.
So source.
Source, yeah.
I have
Source.
off-topic question. Oh, sorry, go ahead.
Yeah, no?
So off-topic question is about force tunneling you mentioned, right?
Mhm.
From ASE, and we can have a routing table which can override the force tunneling.
Yes.
Yeah. Does it same apply for normal VNet also? Not ASE.
Yeah, so if you had take the ASE out of the equation, right? You had a regular VNet,
Yeah.
and you had some resources in there, and those resources were isolated, right? You don't want any route out to the internet. You can force all that traffic back to your enterprise network.
Correct.
Yeah.
Force tunneling works there, but if I want to override that, can I?
You can still use a UDR.
Yeah.
So a user-defined route table is a VNet resource.
Hmm.
So you can attach that to a VNet, and that's just a basic construct of your networking. Yeah.
Thanks.
I have a question.
Yeah.
Do you guys run a user group?
Yes, we do.
Yeah, we haven't met for a while, but
We do a couple. There's the Enterprise Cloud User Group that
Yeah.
we host in the source offices, and we also co-sponsor the Toronto Azure User Group
And how would people find that?
on the internet. It's the Toronto. There's a meetup. So
so there's Enterprise Cloud Meetup, and that'll find the one that the source puts on. And then there's the
Toronto Azure User Group.
Azure User Group,
which is also a meetup. Yeah.
Yeah. What else? There was one other.
Oh, the
one.
Puppet. We also do Puppet.
We also do the Puppet User Group, so we're a co-sponsor of that.
Yeah. Also in Toronto.
Yeah.
So if you're in Toronto and you want more cloud, check them out.
Yeah.
Yeah. Awesome. That's great.
Okay.
That's great.
Thanks.
Thanks.
All right, stretch your legs for 5 to 10 minutes. Calvin is here. He's going to get set up, and he's going to talk about Event Grid for the final talk of the day. So there are still a couple of sandwiches left. There's more drinks left.